Hey, everybody, we're going to get started here in a minute, so go ahead and find your seats, get your last-minute lunch items down, and that kind of stuff, and all that good stuff. My name is Aaron Baker. I'm on the committee, and I have the great pleasure and honor to introduce one of my own colleagues, the open data sorceress, I guess maybe is how she sometimes referred to herself. But she really is an excellent colleague, and I can speak from personal experience that within our company, her expertise is highly desired and sought after, and she's torn 5 ways to Sunday because just of her extreme competence that she has. So it is my great pleasure to introduce someone that I respect very highly from Captech Consulting, Calli Rogers.
Thanks, Aaron. Oh, can you guys hear me? There we go. All right. Might have helped if I plugged this in before we got started. Oh, come on. There it goes. All right. Plugged in. There we go. So I'm going to be talking about the role of a machine learning engineer on an advanced analytics team. And what in the world is this ML ops that everybody keeps talking about? So this talk was inspired by one of my recent clients, a bunch of PhDs, data scientists. They all have a variety of health sciences degrees, self-taught coders, phenomenal humans, some of the smartest people I've ever worked with. They had no idea how to productionize their models. Every single month they were manually running their feature set generations, dumping out Parquet files, and then running 22 models by hand. So I was like, hey, I can help with that. So that's what this talk was inspired by. And my clicker. All right, we're gonna do this way. Sweet. Ooh, that's working. Haha, I was hitting the wrong button. Little about me. Believe it or not, my hair is not naturally blue. I know, shocking. I am actually itching to get to the next color. I've had the blue for about a year and a half. I told my hairstylist that it is up to her. So if you see me sometime after April 21st, it might be a different color. We'll see. It's been almost every color of the rainbow. I love travel, live music, video games. I am going to Kansas City in June for a music festival. I'm going to Germany later this year. If I can combine those passions, I do it. I have been in more wedding parties than I have actually been only a guest. But I have 2 more weddings this year that I am only a guest. So we're gonna make it tied here. And then fun fact, I accidentally fell into coding and data as a career. I was doing it kind of as a hobby and just for funsies, and I just kept writing it, and turns out I wasn't that terrible at it. And then I prefer talking to people over talking at a crowd. Talking at a room is very difficult for me. You're gonna hear me say a lot. If you want to talk more about this, come find me. I would love to geek out. Now my buttons are working the right way. Cool. So enough about me. Let's get to this talk. I want to talk a little bit about the difference between a software engineer, a data engineer, and an ML engineer. I've been all 3. And then I want to talk about ML ops. I promise it's more than a buzzword. And then if we have some time, I've got some code to show you. I've got some things to think about, and just get you under the hood a little bit. So this is the only slide that will have this many words that I wrote on it. I don't like slides with words. So software engineer, I mean, we've all heard the term. It's a broad, long-standing role. They can do a variety of different things. A lot of times they're specialized in a variety of different stuff. If you're a hiring manager in the room, they might be the right person for you. They may not be. It depends on what the skill sets are and those sorts of things. So different strengths. They can do DevOps. They have coding best practices. They can serve up an application. They may even be able to make some pretty visualizations. I certainly can't, but some of them can. but they're not really going to understand large data sets, data movement, some of the analytical side of things. And you're going to lose that a little bit. If you've got strong data scientists that know that stuff, totally fine. That may be the right person for you. If you don't, if you have the PhDs that I had, software engineer wasn't enough. They were going to need a little bit more. So data engineers, still pretty industry established role. Obviously, they know distributed data, they know big data, data governance best practices, usually have data ops, which is that little bit of weird DevOps. But operationalizing models and that sort of stuff from an application serving perspective is probably going to be a little lost on them. Chances that they can serve up a model from an endpoint is not going to be something that they can do very well. They can figure it out. I did. But it's not going to be their strong suit. And then an ML engineer is newer. And if you go look up an ML engineer job post right now, there are 27 different varieties of them. I was trying to look them up to see what people are hiring for, and I don't think anyone knows what it actually means. So hopefully I can clear that up a little bit. So I have a list of important skills here. Ideally, they have some form of ML ops, DevOps, data ops, some kind of ops. They can actually do application or model serving from an endpoint. They can do the batch stuff. They can do the monitoring. They have both operational and analytical data consumption and production. They can containerize stuff. They know what a Docker container is. They know what Kubernetes is. They're good at data governance. They can do versioning. Please put things in Git. Source control is so important. And they can do a lot of that stuff. So it's a really cool space to be in. I'm one of the weirdos that finds this stuff absolutely fascinating. But I very much enjoy it. So in short here, these are the 4 things that an ML engineer does. They can deploy it, they can automate it, they can monitor, and they can optimize. But I saw a ton of job posts that were like, hey, we also want you to know the statistics, and we want you to be able to discover the business intent, and we want you to be able to do the exploration. That's not what you pay your ML engineers for. That's what you pay your data scientists for. That's what they're good at. Let those people do what they are good at. That is not for the ML engineer to do. You want them to do everything else? Sweet, do it. Let your data scientists do what I call the hard stuff. All of these fun things, I can't do them. So let's talk a little bit about ML ops. First off, I hate this graphic in the background. If you've seen it, if you've worked in the industry, I hope you hate it as much as I do. It oversimplifies what ops is, what ML is, what dev is, all of it into 8 words. It's too complicated for that. You send that to your leadership and they're like, oh, we can do that. No, because it looks more like that. This is a little bit closer to right. So I tried to build this out in a day and a half to demo to you guys. Turns out it takes longer than a day and a half to build this. So I've got some stuff to show you and some things to work through. But if we work from left to right, obviously I got this fancy clicker just for this, so you guys get to see it for the first time. This is where your data engineers are really going to live and thrive. They're going to be moving your data in. It could go in a feature store. It can go in a data lake. It can go in a data warehouse. It can go anywhere you want, some sort of data store. And then you've got cleaning, validating, transforming. If you have written any data science models, you have done that as many times as you've written a data science model, maybe more. And then the fun stuff, and labeling if you need to, if you're doing classification and that sort of thing. Training, you got to experiment, train, hyperparameter tunings. All of that eventually comes out to the train model. You guys should know this at this point. Even people who don't write data science models do this sort of stuff. Then you deploy it, put it out there, prediction inference either as a batch model or as an endpoint. If you've got some form of monitoring that comes through, you come back and train, do it again. None of this should be surprising. What ops is supposed to do is automate all of that so that your data science team is focused on writing the code that does this and maybe some of this so that they can get the features they need. Everything else they shouldn't have to worry about. So when I went to the client that I mentioned that prompted this talk, this is very, very close to what their process looked like. And you can see image credit. This actually comes from a GCP blog, but I was shocked at how close this was to what they were doing. In fact, they didn't even have the model registry. They stored everything in, at the time it was HDFS, we moved them to the cloud, so it got dumped into buckets, but it was very, very manual. Everything they did was by hand in a notebook. There was no concept of dev versus production. Everything was done in production. We actually couldn't retrain a handful of the models because the people who had written them had left the company, and we couldn't figure out which which actual training files they had used because they had just stored everything in, wasn't even in source control. I'm telling you, put everything in source control. But so it was a mess. And I think something like 7 of their models are not retrainable still. They're in the process of rewriting them. God love that team. I quite frankly don't know how they have managed, because they had 20-some models that they were doing this with every month. And then they had 3 models that ran every day. 4 of the 8 people, their entire job was just this part right here. That's it. That's all they did. No. Wait. You pay them too much to do that. So we got them to something a little bit closer to this. So the great idea is you have an orchestrated experiment. And yes, you still have to write the code for this. Don't get me wrong. But once you write it once, it's there. And you can just run that pipeline. And they went through all of this stuff. And then source control. I'm telling you, put everything in source control. And then we had stuff that actually set up a pipeline deployment that built Docker containers that would retrain their models, the ones that we could get retrained, and everything like that, so that it went in and stayed in this automated pipeline, so that when we did need to retrain it or anything like that, they didn't have to do it by hand. Ooh, pushing buttons. Went into a model registry so we could keep track of the versions. We did that with Docker containers specifically for theirs. And then they were all batch. We didn't have to worry about putting them on endpoints, but we had them scheduled through Airflow so that they ran. Everything was very automated. We had some performance monitoring on it. We specifically helped them implement bias and fairness audits, which I thought was really, really neat, something they were very passionate about. They partnered with MIT to be able to help with that stuff. We did not give them a feature store. I could do a whole talk on feature stores. I will refrain. If you're interested, come find me. Again, how many different ways can I show you the same thing? So here's another view of this. This is really gets down a little bit into the nitty-gritty of what this looks like. And again, this is no way sponsored by GCP. I just happen to really like their data science platform. I have seen this done in AWS as well, and I'm certain it can be done in Azure. I think I logged into Azure once. So ideally, your data scientists work in your data science environment. If you're using Vertex AI Workbench, that is a Jupyter Lab notebook. They have all kinds of cool stuff in those Jupyter Lab notebooks. You can do Spark, you can do R, you can do Python, you can install your own custom kernels. It's actually really nice. And so they should be, ideally, writing the stuff that does all of this. But they should write it once, and that should be all they have to do. And they can then use their platform to orchestrate their experiments, everything like that. Your ML engineer from there is going to use all of this stuff that is written, that they have hopefully templated and fairly automated, to build out Docker containers, Python packages, anything that they need there, and be able to orchestrate this. And then Cloud Build is their equivalent of Jenkins if you are familiar with DevOps. If you are not, it automatically builds your stuff in the cloud. Another thing I appreciate about Google's tools, they're pretty well named. And then from there, things go into an artifact registry so we can keep track of the containers, the versions, the code, everything like that. And then we're able to just flip through all of this. So all of that's well and good, but it helps a whole lot if you can actually see it. So let me see if I can get this to do what I want it to do. Give me a sec. Oh, look at that. I swear I know how to use technology. All right, so something I was talking a little bit about was, or something that last slide had was pipelines. This is Google's Vertex platform. If you're more familiar with AWS, SageMaker equivalent. I've been in the Vertex space now for about 3 years. I've gotten pretty good at kind of being able to use it. So this is a pipeline. This is built on top of the open source Kubeflow, however you want to pronounce it. Same way as you pronounce Kubernetes, I think. This is a very, very simple one that they actually have out on their in their documentation, kind of a getting started, get your feet wet type of thing. So basically what this does is this uses Google's AutoML for image classification. It pulls a 3,000 image, I think, data set out of one of Google's buckets, does the training on it, and then deploys it to an endpoint and pushes it out there so that it's ready to go. I ran this by hand to make sure that I understood I knew what it was doing before I pushed it out there, which is why you see all these little no signs. If it actually runs correctly, those will be nice and green. But you can see the artifacts in between. These are all things that it stores under the hood. So if you ever need to go see what data set your model was trained on, if you need to see what version of the model, you need to go back to an older trained version, anything like that, you can go get those, which is so, so important for governance. And I know a lot of times that's always an afterthought in data. But I'll tell you what, the last thing you want is somebody to audit you and ask you if you can prove that there isn't bias, and you can't because you don't know what it was trained on. That would be absolutely terrifying. So let me show you the data set that it would create. So Google has this concept called managed data sets. I created it twice. Cool. Has this concept called managed data sets. And these are really cool because you can pull these in. So these are a series of images that are going to not load. Here we go. And this is your training set. You can look at it. You can actually dig through it yourself and use it this way. You don't have to use managed data sets. I like them. They're kind of nice. If you don't use the managed data sets, you've got to use custom training. Anybody that I've worked with in an enterprise environment does custom training anyway, so that's not really a big breaker. But if you're just playing with AutoML like I do, this is a phenomenal way to visualize and look at your data and everything like that. You can also train a new model right from here. You can click on the UI, all of that stuff. It gives you some really cool analysis stuff in here. Again, I promise this is not sponsored by GCP. I just really like these tools. So I went ahead and trained this last night because it takes a couple hours. It's as easy as click and create, train. You can do all of it. And it gives you all of this really nice stuff. If you do want to see this in detail, I would be more than happy to sit down and talk with you and show you some of this stuff. And then the other thing it'll do is create an endpoint. I did not create one because I didn't want to forget and leave it up and have my IT guys get mad at me because I ran the bill up. But if we look back at the pipeline, like I said, all of that happens automatically through here. That's all well and good, but you just saw me click through, and it's like, all right, well, I can do that myself, and it takes a couple of extra minutes, no big deal. And for development, experimentation, spot on. You should do it by hand, probably, be able to stay in control of it and things like that. These pipelines are nice, but they're not really going to help you with that side of things. But what it is really going to help with is when you've got 30, 40, 50 models that all need to be continuously trained either on a schedule, or you start getting some data skew, or some major event happens and you have to retrain, something to that effect. You don't want to have to be going back in here, recreating your data sets, retraining all by hand. You want this to be able to be here and do that for you. So that's where these pipelines really, really come in handy, is to be able to click one singular button and this runs and it's taken care of. Even better, don't even have to click the button. You've got something on a trigger. That's where your ML engineer is going to know what they need to do, how they need to do it. In Google, there's a handful of different ways to do it. I would probably schedule it, have a cloud function, Lambda if you're AWS, run through and be able to trigger my events whenever I need it to. If we did it on a schedule, if we were looking for a major change. The cool stuff about the feature stores and everything like that is that they can actually monitor that and those sorts of things. If you start getting some drift in your model, there is a bunch of stuff in here that will be able to track that for you, or you can write those yourself and include those in these pipelines. There are all kinds of different things that you can do with these. They're really pretty effortless. Like I said, I don't data science, and I was able to run a model and get it to predict that a flower was in fact a rose last night. Thought it was kind of cool. So that's really at its core. That's what this looks like, and on a small scale, this makes a whole lot of sense. Big scale, how do you orchestrate all of that stuff? Vertex is not good for that. One model, you can have this set up for any number of models, and for any number of models, this singular pipeline makes complete and total sense. But again, how do you do it for 20, 30, 40, 50 models, hundreds of models? How do you make sure all of that's orchestrated? There are dozens and dozens of tools. My favorite one is Airflow. Google has a managed one called Composer. AWS has a managed Airflow. I think it's just called managed Airflow. Airflow is really cool. I did not get one stood up because I was fighting with the Terraform. But I do have a couple, I do have a couple screenshots back in here of some actual examples. So this is an actual example from that client. I did scratch out the names of things and that sort of stuff, so it's all anonymized. But this was an ephemeral cluster. It was specifically a sparkly R model, which is not something I see very often. So that was an interesting challenge on its own. We built a Docker container that stood up on that cluster that would then distribute across the cluster, run through, either do its training or scoring, depending on which pipeline we wanted it to run, bring the cluster back down, and be able to give you the outputs and everything like that. So this is an Airflow DAG, directed acyclic graph. These can get very, very complicated, but this was just our very basic pipeline for retraining or scoring production, depending on that trainer score. And you can see it's not very complicated. We also had a dever prod. There were reasons for that, environment sorts of things. But flip through, you can see this particular run happened to fail on scoring. Turned out the data wasn't there. The new data wasn't there, even though it was supposed to be. I just happened to still have this screenshot. But we actually had it set up so that that trainer score would invoke one of those Vertex pipelines that would look at monitoring and make that decision, pass it back to Airflow, and then Airflow would pick either score or training, which then went back to a Vertex pipeline, and be able to run those through the Docker containers and invoke the clusters and all of that fun stuff, and finally delete the cluster and work through it. So even though this looks really simple, under the hood there was a ton going on. And we did this for 20-something models. This is what their monthly process looked like. And I blacked out all of the model names on the off chance that somebody somehow recognizes them. Just trying to keep my clients protected here. But we also implemented some fun monitoring data checks and that sort of thing. So we have a table checker that checks the last loaded date. Are things different? Are all of the tables loaded? Everything like that, making sure that our data's right. And then we've got these 3 feature sets. You may or may not find them. 1, 2, 3. These were different versions of the features. Different models needed different features. But we were able to pretty much condense them into 3 different feature sets, dump them out into a Parquet file, and then once those features got generated, we could run all of these models. We also had a couple that didn't use the feature sets. I believe this one was a Python NLP model. It had its own data. I forget what the other one was. But we had them all run together. We also had a couple models that relied on each other. So this is one of my favorite things, is that we were able to orchestrate, once the feature's finished, run the first model. Once the outputs of that are done, go ahead and run the next model. So you can really make with Airflow as complicated or as not complicated as you want. You can put your feature engineering in here. You can put your data engineering in here. You can put anything you want in here. It is very, very easy to use. It's all Python based, which is really nice. And then at the end of all of it, we did a schema check because all of these models had a standardized output that went to consumers. It actually went into a dashboard that was used for real life. If you ever got a call from a health coach or something like that from your healthcare provider, that's what this data was being used for. So they were using that to be able to look at different things, which was really, really neat. It was actually really cool to be able to help automate that and push that forward and get those nurses that were using this data that much faster. I was always very, very impressed with it. And again, I couldn't write a single thing about any of these models. I don't know the first thing about what the onset of diabetes might look like or anything like that, but they did. And they could write models that absolutely would knock your socks off. So with all that, I'm a coder, I'm an engineer. You guys have kind of seen what it looks like, but what does that mean for the code? So you can ignore all of my markdown. This is in progress. Like I said, I tried to give myself a day and a half, and it turns out I can't do that. Those pipelines, that very specific one that I showed you, looks like this. So this is Kubeflow, KFP, Kubeflow pipelines. This does that. This is a very specific Google one, does the data set creation. You've got the AutoML training, endpoint creation, model deploy. Nice, easy, clean. Of course, this is what Google's going to put on their documents. This is copy-pasted straight out of some of their examples. But if you look at this and really break it down, let's create some sort of operation that creates our training data set. Makes complete sense. This can be a custom operation, whatever you need. If you can write it in Python, you can put it here. One of the Google guys did tell me it supports more than Python. I never quite figured that out, but I trusted that particular engineer, so I'm sure there is a way. It might be Docker containers, because it can run Docker containers. Training job, you probably have some sort of custom training job, that sort of thing. And then when it is done, you do want to do the endpoints. But training job, one of my favorite parts about this is all of this is included. If you want to do the training, validation, and test right in here. I believe the AutoML ones also do hyperparameter tuning, but all of that can be included as well. So looking at all of this, and I'm going to get real deep here a second. What, as a data scientist, do I actually care about? What do I want to do? So I've got this sample project, and yes, it's all in one folder. I am going to put this out on GitHub, and it will look so much cleaner when I do. I promise. So I've got my notebooks. This particular one is a data exploration notebook. This was just me experimenting, playing with it. This is what I would use in Vertex, in those Jupyter labs, to work with it. From there, I'm going to write some training code. You can see I have a training module here. I think it's 3 lines of code right now because I just needed a placeholder. But that's there. And then eventually I'm going to write my production prediction scores as well. And as the data scientist, and then of course unit tests, feature testing, please test your stuff. But those sorts of things. But once I have that, as a data scientist, I don't want to think about it. I don't care how it runs. I don't care what it does. And that's where your engineer comes in. So in a absolutely glorious, perfect world, your engineer is going to go, OK, cool. This is going to run as a series of Python packages. So let me build, and can I make this bigger? View. I thought Zoom was in here. Aha. That's a little better. So this is setup tools from Python. If you've written Python, if you've ever generated a wheel or a zip file from your stuff, this is the clean, easy way to do it. So in a perfect world, in your MLOps pipeline, this is going to exist as a step in your get a little bigger. There we go. This is going to exist as a step in your actual pipeline. So you will have something that just automatically runs this. And every time something gets pushed up from Git, which is great, but what about training? Well, I've got one here too. Just looking at source train. Why are we still highlighted? Here we go. So by having that split in that source space, we can dump it in, and it can automatically pull everything when it's ready to go. I do not have that cloud build set up, so we're not going to open that. But then, ideally, once all of this is taken care of, it fits into one of your pipeline templates, and it's just a matter of generating your calls to that. And everything happens automatically and wonderfully, and everything's perfect. We all know that's not how real life works. But that gives you a really great starting point, and for your simpler models and for your models that do follow a pattern. You don't have to worry about pushing it to production and doing all of that. It's all there and taken care of and scheduled and all hunky-dory for you. The downside to this, as an ML engineer, this takes a hot minute to build. And so a lot of people are like, what are you doing? And it's really hard to show. I had to pull up code to show you guys. And then people have no idea what it does or how it works until it breaks. As an engineer, I have come to terms with that is a pretty thankless job. Honestly, part of the reason I wanted to do this talk is I wanted people to see just how complicated this is and what everybody's doing under the hood. If you do have an ML engineer or a DevOps engineer, thank them. They've made your life much, much easier. Like I said, there's a lot in here. I am actually going to put it out on GitHub. I would love to sit and talk and dig through a ton of this stuff with you guys, but I know I've got a wide variety of audience here, and I don't want to completely bore everyone. So I'm just going to stop and ask if there are any questions. Oh. Sorry, Aaron, I put you on the spot here.
Yeah,
I didn't warn you.
All right, I'm coming from the perspective of an analyst from a small company, and I've been dabbling in data engineering, but what do you see as the core skills to kind of bring you from data analyst to data engineer?
That is a phenomenal question and something I have been struggling with at my company as well. We have a ton of people that have done data analysis for years, and they want to get into engineering. For those folks, a lot of times I like to look at it at the operational level. What can I automate? What am I doing in Excel that I could write a Python script to do? How do I make that Python script run on a schedule? That sort of thing. So if you're in a cloud space, let's say you're in AWS, understanding how a Lambda works, how you can schedule it, how you can trigger it. Data engineering, being able to figure out functional programming. I have been very shocked at the amount of procedural code that I see come out of my data analysts. But then I think about it and it makes a lot of sense. What they do once. They don't really need to write functions. Abstraction, those sorts of things. Things that, I don't know if we've got any software engineers that went to college for software engineering, but that's the stuff that they taught us in school that unfortunately as a data analyst you didn't get. And that usually didn't get. That's the kind of stuff that really helps and really makes the difference between analysis and engineering. It's a lot of that automation stuff.
Any other questions? Oh, hey, we got an audience here today.
Oh boy.
Closeness and smiled. A joke from a prior session. If you weren't here, I apologize.
Hey, so from a client explanation kind of perspective, when you're talking to the business about what they need, it seems like you have some experience with the general understanding or maybe lack thereof of like what a machine learning engineer does or should be doing. What is kind of the approach that you take to that consulting perspective to say, here's what you need from this skill set and like why this might not be the right choice or it might be?
So if my biz dev guy is listening, he's going to roll his eyes as hard as possible. I usually leave that up to him because he's better at that than I am. But when I do get in a room with somebody and I'm talking about it and they're like, why do I need engineering? Automation sounds great. Sure, you can give me, I'm saving time, all this stuff. But I have 6 models and 3 data scientists. Do I need this? Generally speaking, my answer is maybe not right now, like especially in that situation. 6 models, 3 data scientists. But what happens when you grow? What happens when your business expands? How much time are those 3 data scientists right now spending on running those 6 models? What happens when you need them to build another one and they don't have time? That sort of thing. Investing in it early makes it so much easier to scale. You can keep going. You have best practices from there. You're not going backwards to try to re-engineer stuff. Like I said, we had 20-some models, couldn't retrain a handful of them because we didn't have the code, because we didn't have the tacit knowledge. All of that should be automated, easy to use. Another thing I've seen at other clients is they're like, oh, we don't need to retrain. I actually had a client say that to me, and I said, you haven't been doing data science very long, have you? So it gets very interesting. Being able to sit down and really talk about this stuff is hard. Data engineering, ML engineering, nobody knows what we do until it breaks, and then my phone rings at 2 in the morning. And someone knows what I do. But being able to articulate that, it really is a business by business problem. It really is a group by group use case. One thing at a time. I can easily say, oh, well, based on that, here is how much time you're estimated to save. Here is what you can be doing instead. Here's how we can propel you. That's not how, I don't sell. I'm an engineer first, consultant second. And, okay, Eric's not in the room, excellent. I would prefer to sit down and explain what benefits your people are going to get out of it and how much happier your people are going to be and how much better this is, because from my perspective, that is going to increase your business value at the end of the day. So that's always the perspective I take. If somebody wants to know what are the numbers, how many dollars am I going to save, I've got business development people who can do that.
Any other questions?
So from what you showed, Vortex AI is a cloud Kubeflow. Mm-hmm. Does it have a full support, like whatever the Kubeflow is right now, or is it just subset of the Kubeflow?
Full support. So Kubeflow is an open source pipeline. If you're familiar with MLflow, it's very similar. Google just opted. Google is all in on Kubernetes. If you get into some of their stuff, all of their managed services are on Kubernetes. So if K8 builds it, Google's got it. So they went with that one. There's custom things built for the Google environment, but you can go completely cloud agnostic on it. You can do all open source tools. You can do everything through Docker. You can do everything through whatever you want. You can stand up your own Kubeflow. So if you don't want to use Google specifically, or you want to be able to go multi-cloud, or you want to be able to get out of the cloud at some point, or whatever you want to do, there's a lot of flexibility there, which is why I like the Google stuff, because yes, it's proprietary, but it's built on top of open source, and it makes it really easy to be able to migrate and move and honestly look things up. Stack Overflow is my best friend.
So specifically to the Docker containers you're mentioning, I know for, let's say, on-prem Kubeflow, we could, in the serving of the model part, so you have your training pipeline, and now we want to serve them. Recently they have a component called kserve to allow us to serve these models, which out of the box supported TensorFlow, Google Protobufs, PyTorch, XGBoost. Let's say I have a custom model, Cat Boost or something like that, which does not, I can't serve it. You mentioned you can actually build a Docker container that has all the same interfaces, and you can actually serve it via the same way.
So the way we actually did that in Google, you can do it as a batch, which at that point you just have a run command and you can just run your container, stand something up and run it whenever you want it. Or we also used Google's Cloud Run and I think we used Flask. Getting a little bit into services there. Again, this is where your software engineering may actually come in handy. But we used Flask, which is a very lightweight API type of response product, to be able to serve that up and have endpoints so that you can just hit it with whatever data you needed. I think all of ours were date-based. I know a lot of models are generally date-based. So that was how we did it, was just pass the start and end date in and go from there.
All right, I know we had a question over here, so I'm going to hand it off.
Thank you, sir. Hi, my name is Javier, and I wanted to ask you a question regarding model monitoring. So how do you standardize model monitoring? Because I feel that there's a lot of data scientists, and they love to create models, but if nobody's watching them, they're essentially just fairy tales, predictors.
Yeah. So I actually thought about doing a whole subsection on monitoring, and I got so far in the weeds that I was like, I can't. There are thousands of tools out there, and none of them are going to work for every model. But there are lots of things out there that you can do to monitor drift. That's the big one that I always see. But something that's very interesting that the client that inspired this talk was very big on was bias and fairness. And that one's a really hard thing to model. So that's something, or to monitor rather. Those types of things, looking at accuracy and the different scores going back, the data scientists aren't going to think about it. That's really where a very high-performing team is going to have an MLE that's going to be able to start building a lot of those monitoring things so that it can go back and retrain and you don't have to go bug your data scientist. Again, perfect world. I don't think I have seen a full end-to-end perfect team MLE pipeline in the industry yet. Doesn't mean it's not out there. I just haven't seen it. But there are different ways of doing that, and it really depends on what your models are doing as to whether or not what you need to monitor and how you monitor them. And then you get into some of the more software basic stuff where performance monitoring from a timing perspective, this is starting to take a lot of resources, a lot of time. There are so many things you can look at that just go beyond that.
All right, last question. I think TensorFlow has one pattern for model monitoring, or maybe more than one, but I don't know much about it.
I know just enough to be dangerous.
Thank you. Hi, my name is David. I have a question about your thoughts of embedding an MLE as part of a data science unit versus an IT department.
Very good question. I have seen it done both ways. It really depends on the organization. I personally like working very closely with the data scientists and partnering with the IT. But that is also because I come from a very strong IT background, and I can usually reassure an IT team that, yes, I am going to do things the proper way. I am going to deploy. I'm going to use your Jenkins instance. I'm going to use your Git. If you are a very regulated industry, you almost have to have that person on the engineering side because they have to be in charge of those regulations. But that's not to say you can't have the relationship there still. You could do either. You really could. I know places in Richmond that do it both ways, depending on which organization you're in. Some of their engineers are on the business side, embedded in their data science teams. They don't have an ML engineer title, but that's what they're doing. I know other ones that they have their software engineers as their title, even though they're doing ML on their IT side. Either way, it's going to be a very, very strong relationship on both sides. You have to be able to be in that middle, and it's not an easy place to be.
All right, well, we're at time, and as Calli mentioned in the beginning, she'd rather talk to you face to face, one person to person, so we'll let her get off the stage, and if you have any other questions, you can talk to her in her preferred format, as it would be anyways. But let's give a round of applause for Calli and her talk today.